Welcome to the empirical formula lesson. The empirical formula, in short, is the simplified version of the molecular formula and the molecular formula is really just a real chemical formula of the compound. And the way you find the empirical formula is first you want to get to moles. Moles always seem so relevant. And you want to check for the least amount of moles. And divide each value of moles by the least number of moles. And when you're given these percentages, just act for 100 grams in 100%. So let's start by going through this first example. A compound is composed of 54.5% carbon, 9.1% hydrogen, and 36.4% oxygen by mass. Determine the empirical formula. So again, we act like these percents don't even matter, and we just get to grams. So let's just do that for all of our different elements. And here, oxygen wouldn't be diatomic because it's grouped with other elements, so don't be confused by that. And don't forget the gram symbol. So now I'm gonna cancel. And so this is where things get a little tricky because you want to be as precise as possible because these values can be incredibly narrow. So this one's gonna be, I'm putting the wrong values, 12.01 grams of carbon, and then 1 mole of carbon would show up here. And this one's hydrogen, so 1, and then 1.008 grams of hydrogen, 1 mole of hydrogen, and then 16 would be a good indicator, and then 1 mole of oxygen. So I use the molar masses of each element to get to moles. And so let me calculate these values now. So 54.5 divided by 12.01 is going to give me roughly 4.54 moles of carbon. The next one would be 9.1 divided by 1.008, and that would give me roughly 9.03 moles of hydrogen. So that's not really going to be my lowest value. And the 36.4 divided by 16, that would give me roughly 2.275 moles of oxygen. So I can tell that this is my least number of moles. And so now that I know that, I can easily divide all of these by 2.275. 2.275, 2.275, 2.275. And the reason I'm doing this is to find my ratio. So 2.275 is going to give me roughly 2. So that's going to be my ratio for carbon. 9.03 divided by 2.275 gets me roughly 4. And then obviously this one gets me 1, so it's going to be 2 carbons, 4 hydrogens, and then it's going to be 1 of these oxygens. So that would be my empirical. In this next example, we have a sample contains 82.76% nitrogen and 17.24% hydrogen by mass. Calculate the empirical formula. So as we've done in the past, 82.76 grams of nitrogen. I'm just going to change these percents. I don't know why I put 17, but change these percents to grams of the element. And it used the molar masses of these elements to get to moles. So in this case, nitrogen is around 14.007 grams nitrogen, 1 mole of nitrogen. And then for hydrogen, it's roughly 1.008 hydrogen grams, and then 1 mole of hydrogen. So now I just need to do a couple of calculations. So 82.76 divided by 14.007 is roughly going to get me 5.91 moles of nitrogen. And the other one is around 17.24 divided by 1.008. This is going to get me roughly 17.103 moles of hydrogen. So now I just need to see where my lowest number of moles is. So my lowest number of moles is 5.91. So I would get 1 nitrogen, and I would get how many hydrogens? Let's see. So I divide by 5.91. 5.91. So only calculation I need to make is the hydrogen. And that gets me roughly to 3. So that would be NH3. In this final example, a compound is found to contain 40% carbon, 6.7% hydrogen, and 53.3% oxygen by mass. The molar mass of the compound is 180 grams per mole. Determine the empirical and molecular formulas. So our strategy for empirical is going to be converting these percents to grams. So nothing really changes about the empirical. For now, I wouldn't worry about the molecular. Only one at a time, so calculate the number of moles via the molar mass. So carbon would be around 12, 1 mole of carbon. For hydrogen, and then for oxygen, around 16 grams. Whoops, let's just say 1 mole of oxygen. So now I need to do my different calculations. So 40 divided by 12 is around 3.33 moles. So 6.7 divided by 1.008 is roughly 6.65 moles. And for the last one, 53.3 divided by 16 is roughly 3.33125. So let me just check the other one. 40 divided by 12.011. That one was 3, and then it had 0. So it's really important to sort of check. So if this is the case, then the number of carbon moles is going to be the least. So divide by 3.330. So there's going to be 1 carbon. For the amount of hydrogen, it's going to be around 2. And for the amount of oxygen, it's going to be incredibly similar, which is just going to be around 1. So carbon, hydrogens, and oxygen. So that would be the empirical. So now we have to use the mass of the empirical. So the steps are going to be masses of the empirical and dividing that value from 180 to get our ratio to plug back into our empirical. So 12 plus 2 plus 16, 30. So 180 divided by 30 would be 6. So multiply 6 through the empirical. See 6H12O6. So again, the empirical is the simplified form, and the molecular is the actual. Thank you for watching this video.